So this is Pure 2, chapter 2.2 about functions and mappings. So notes, a bit of writing to begin with. So first of all, we have to know what is a mapping. So first bullet point, a mapping transforms one set of number okay, where do I, oops, so select, sorry, one set of, let's try again, one set of number into a different set of numbers, into a different set of numbers. This can be done via words or via an algebraic equation, aka a function, and can be represented by a graph. So function machine, so that's the first bullet point in here. So that's the first bullet point, second bullet point. A function machine is a type of mappings. Okay. So e.g., if you've learned before about, let's say if we put it, so x, and then in here, let's say we have times it by 2, and then we have plus 3, and we get y, then we can put anything into x, that's the input, and it will map into a different value into y, which is the output. So that's the input, and that's the output. So it maps you to a different value, whatever you put in. Say, for example, if you put in x is 3, 3 times 2 is 6, plus 3 is 9, then is output is 9. That means you're mapping, this machine helps you to map 3 into 9. If you put 4 in there, quick maths, that's 11. So it helps you map 4 into 11. So anything you put in there will get different values coming out. So this is called a mapping, okay? And function machine, one of them. So express the function machine as an algebraic equation or function. So in here, we can see f of x. We can write f of x equal to 2x plus 3. So 2 times x plus 3, so it's 2x plus 3. Now, if we want to write as a mapping, as a function machine, that's f of x as a function. But as a mapping, we have a different way of working out. Now, this mapping, we call it f, okay? So you got different mapping, like g could be h, like g of x, h of x, different, it's just the name of it. F, so, and then colon, x, which is your input. Now, mapping is a symbol like this, arrow, but with a line in the front, into 2x plus 3. So this symbol here, it means maps. So we're mapping x to 2x plus 3. Okay, right. Next one. I don't know if you can see my name. There's my little name tagging in here. I don't know what's happening. Probably a glitch. A mapping is a function. Okay, hopefully it's gone now. A mapping is a function if every input has a distinct output. If you've got highlighter, highlight this. Every input has a distinct output. That means each input only gives one output value. Now, there are three types of, we can see three type of functions in here, but not all of them are mapping function. So let's look one by one. Now, there are three scenarios in here. Let's look at one by one. The first one here. Now, the left circle represents input, and this one means output. So that's input, output, input, and output. Okay. Now, this is called one-to-one function because one input maps to one output. I'll give you an example in here, e.g. So this one for this one, e.g. If we have f of x equal 2x plus 3, okay, every value of x gives a different output value. Now, there are no value will give, sort of one value will give two outputs, or one or 2 inputs will get the same output. So each of them has a different output. What they put in there has a different output generated. Depends on what you put in there. Now, the second one is called many-to-one function. So many-to-one function means many, or means more than one. Many inputs gives one output. So many, you can see these two values. So these two inputs, these little dots, give the same output in B. I'll give you an example in here, e.g., if with f of x equal x squared. Now, if you have x equals to, let's say, 3, or x equals to -3, both gives f of x equals to 9. So 2 inputs, more than one input, give the same output. Okay. So this is called many-to-one function. Many x value to one y value. Now, last one is not a function. What we call is actually not a mapping function. Now, why is that the case? Let's have a look. Okay, so let's have a look. This is called one-to-many. 1x to many values of y. Now, e.g., if we have f of x equal root x. Now, if I put x equals 4, it will give me the f of x will equals to 2 or -2, because when you square root, you get 2 and -2. Now, but it can't work, because what is the definition of a mapping function? A mapping function means every input has a distinct output. So it's like, think of it like a keyboard. Imagine you press a key, okay, T, okay? So if you press a keyboard T, it should give you, you should type out the letter T. But imagine you press T, but it could either give you T or Y. Now, that's not a really good keyboard, is it? Because if you press T, you expect T to come out. You don't expect Y to come out. So, however, so that's not good keyboard. So mapping function like keyboard. A different way to explain is, for example, many-to-one function. Now, you see in a keyboard, you will see sometimes you will see to control. If using the original Windows keyboard, you see at bottom left and bottom right should have 2 control keys. Now, this is 2, so 2 keys, 2 control keys will give the same function, which is the command control. Or is there any more? Or the Windows button. Yep. So what I'm trying to say is there could be more than one button give the same output, but you cannot expect to press the very same button but give you different output. Okay, so that's not so if things like this happen, we call it that's not a mapping function. So in here, can you write a word? It's not a mapping function. So it's like keyboard. Okay, remember keyboard. So if you press, what you press is the input. What it comes out on the computer or the Word document is the output. If you press a T, you should expect a T. If you press control, there could be more than one control buttons. It should give you the control command. So same thing, okay? Or like a number key. You got sometimes on a keyboard, you've got a number pad, or their numbers on top of the QWER. If you press the 1, you should get a 1. Doesn't matter which one you press, the one on number pad or the one above the Q, you should get a 1. Okay. So therefore, the last one, if you got this also called a one-to-many function, which is not a mapping function. Okay, I hope it does make sense. Now, sometimes it does come up with the exam asking, is this a mapping function? So you will have to realize this is not a mapping function one-to-many. Right. So now let's look at the graphical option. Okay, let's look at it graphically. Now, for a you can split the whole space into three columns. The first one, okay, is a one-to-one function. Okay, one-to-one function. For example, with f of x equals 2x plus 3. Let's say with that one. Now, if I draw a graph in here nicely, and x-axis 2x plus 3 means the y-intercept is on 3, so that means it would be like this. Okay. So this is the graph of y equal to x plus 3. Now, let's look at one by one the value of x. So I'm going to use blue for the value. So this is the input. So if I put 1 into it, if I put an input, okay, so these are the inputs. 2, or even I've -1, -2. I have -3. Actually, that would be wrong. Actually, -1. Yeah, actually, yeah, it doesn't matter. 3, 4. So these are the inputs. And the output is, if we go on here, when x is 1, that would be 5. When x is 2, that will be 7, 9, 11. When x is -1, that will be 1. So these are called outputs. Now what you see is each value of x only maps with one value of output. So these are the solutions. So these are the solutions. So each value of x maps with exactly one value of y. Okay, so you can see there's no overlap. Now, I might not have space to do all three of them, but you should divide the space equally into 3 parts. So that's the second one. We are doing a many-to-one function. So we talk about f of x being x squared. Okay, so this is a mapping function. Okay, so 1-to-1 and a many-to-one is a mapping function. So let's draw a graph of x squared using my amazing bare hand drawing skills. Close enough, not good enough. Right, okay, better, a little bit better. So y equals x squared. So in here, if you imagine this is our input of -1 and 1, they share the same output, which is 1. If you have -2, 2, you can see that's 4 in there. The output is 4. So what I'm trying to show you is these solutions, they are equal. Okay, so as you do more, you'll see so each value of x maps with exactly one value of y. So the fact that we don't have multiple solutions on the same input, on the same input, let's say -1 or -1, yes, they might have shared, but on -1, there's only one output. For the 1, we only get one output. They might be the same, but we don't care. What I'm trying to say is when we press the button or keyboard like 1, we get 1. We don't get any other number. But may share some same values of y. Now we look at the last one, which is 1-to-one, one-to-many. Remember, one-to-many is not a mapping function. I have to stress out because it sometimes does ask you why is there no inverse, etc. You will have to say one-to-many. We'll talk about that later. So let's draw an axis again, but this time I'm going to draw it that way. Root x, the graph root x is actually like an inverted x squared graph. This is what f of x equal root x. Okay. Now, when x is 1, the problem comes. When x is 1, you get two values. Can you see on the x equals 1, you get 2 values. When you have x equals 2, oops. When x equals 2, you get 2 values again. Now, this is not allowed because when you press 1, you expect only one output come out. So this is not a mapping function. So each value of x intersect with the graph more than once. So it's not a mapping function. Okay, right. You don't really have to remember all of these, just for you visually how to see when you put a value of one in there, one input, you show the input should only intersect with the graph once for each input you put in there. So 1, that's 1, 2, and then when you put 3 in there, there's only one value. When you put -1, there's only one value. When you put -2, there's one value. But for this one, when you put 1 in there, you can see the line will intersect with the black curve twice. So that's not a mapping function. Okay. Right. So practice, okay? If you're watching a video, then you might not be able to pair and share, but you can maybe have a go at this question. Decide which mapping is a one-to-one, many-to-one, or one-to-many, and then state whether the mapping is a function or not. When you're ready for the answer, you can press play. Well, okay, so let's have a look one by one. The first one, this is a one-to-many, because one value of input gives many values of output. So this is not a mapping function. Okay. Right, this one is a one-to-one. So it is a mapping function. So it's a mapping function. I'm going to put, mapping function. This one is a one-to-one. Okay, it's a one-to-one. It's a one-to-one because each value of x only gives one value of y. So you can see only one value each time. However, this is not a mapping function. Now, why is that the case? Because x equals 0 doesn't get mapped. When you put x equals 0, what happens to this function? It doesn't generate anything. So for a mapping function to work, all input must work, okay? Unless you state some values that it's not working. In this case, if you want this to be a mapping function, it could work, but you do have to say x does not equal 0. We'll touch upon the domain and range in a bit. So without the x does not equal 0 part, this is not a mapping function. Okay, right. Next one. This is a many to one, many x to 1. Sorry about my handwriting. My mum told me I've got doctor handwriting. That's the closest I could become a doctor. Many to 1, because many x to 1 value of y, so it's a mapping function. Right? Okay. Next, we'll talk about domain and range. So domain is a set of all possible inputs. Now, these two are quite important. You have to remember the domain and the range. So to remember it, domain, if you put in alphabetical order, D is before R. So X is before Y. So domain is for X, range is for Y. Now, if we draw a little diagram in here, just a simple illustration, let's say we have a graph like this, okay? So we have, let's say, I don't know, just make up -5, and here we've got 3, okay? And then we've got 0. Now, the domain is the part on the x-axis. So if you look at here, the graph connects from -5 onwards. Therefore, the domain for this graph will be x greater or equal to -5, because starting from -5 onwards. And for the range, that's for the y-axis. So for the range, you can see the graph in terms of y, it starts from 0 all the way up. Okay, so therefore, the range would be, you can use y greater than 0, greater equal 0, or you can use f of x greater equal 0. So both are equally fine. Okay, so that's domain and range. Right, example in here, let's have a look. The function f of x is defined by, now remember this is a mapping function, f colon x, and then this mapping symbol. So what it means here is this is what we call a composite functions. Is a composite function? It's not. It's a multiple function. I don't know what's actually I don't know if there's a proper name for it. Anyway, the graph basically is disjoint in two parts, depends on the value of x. So if x is less than 1, you follow the first function. If x is greater or equal to 1, you follow the second function. The first one, you can rewrite that one as f of x equal to 5 minus 2x. The second one you can rewrite as x squared plus 3. It's up to you. You don't really need to rewrite this. I'm just showing you, you can change the mapping function back to a normal function. Pi, sketch f of x and state the range of f of x. Now, because the graph is disconnected, we've got two parts of the graph, so we have to do it one by one. Okay, so we'll probably do the draft of each graph, and we're going to combine them into one final answer. So let's do the first graph, y equals 5 minus 2x. So y equals 5 minus 2x. When x is 0, y is 5. When y is 0, x is 2.5. That means the graph looks like this. Now, we have a special number here, which is when x is 1. So we do have to pay attention to that special number. So when x is 1, y is 3. So what it means is, if you've got a pencil, you can sort of shade away this part, because we don't need that part, because x is less than 1. That means we can only include the part where x is less than 1 for this graph. Let's do another one. There's the graph y equal x squared plus 3. Now, this is a quadratic graph. Now, if we think about x squared, it's like this, right? X squared, that's x squared graph. Plus 3 means we move the graph upwards. Using your pure one knowledge, chapter 4, we know plus 3 on the outside means move the graph upwards. So therefore, the graph will look like this. Okay. And again, we got a special number here when x is 1. So we do have to put in 1 in there. So when x is 1, 1 squared is 1 plus 3 is 4. That's 4. This time, we only want the part of the graph which is greater or equal to 1. Therefore, we don't need this. Okay, we don't want that part. So let's put them together. Okay, so this is the final answer. Right, so 1 is a special number we're going to put in there. So when before 1, the graph looks like a straight line passing through 5 at 3. This has nothing to do with it. Right, so that's 1, and that number here is 3. For this graph, because less than means we'll put an open circle in there. And then the y-intercept is 5. For the second part of the graph, when x is greater or equals to 1, we draw the quadratic, the parabola, where it starts from 4. So 4 is... Okay, so that's 4. So that's the complete graph. That's y, that's x. That's the complete graph. That's the answer for part A. Part B, solve f of x equals 19. F of x equals 19, if we put it in graph, the same as y equals 19. So y equals 19 is the graph vertical, horizontal line, like this, passing through 19. So how many solutions are there? Well, there's 1, there's another. So we will have to make 19. So you'll be thinking, which equation should we use? Which function should we use? Because we've got two functions in one graph. Now, because the orange line, the y equals 19 line, passes through both curves or both graphs, it means we have to equate 19 to both functions. Okay. Now, just for argument's sake, if the graph is a bit weird, let's say the graph let's say the graph never touches the orange line. Okay, let's say it never touches. Let's say if there's no this line, then there's only one answer. So we just have to equate the orange line, the 19, to the curve, to the x squared plus 3. But the fact that because we have two answers in here, we do have to equate both. So let's do it. So equate the first one to 19. So 5 minus 2x equals 19. Bring the right hand side. 5. Bring 19 left hand side. So minus 14 equal 2x. X equals minus 7. Does it fit the picture of the graph? X equals minus 7. Yes, it does. Next one. X squared plus 3 equals 19. Bring the 3 over, it becomes 16. Square root 16 is plus and minus 4. Which one do we take? Now we can see the orange line, the 19 passes through the curve on the positive x-axis. So therefore, x equals 4. or -4, reject the -4. Okay, so these two are the answers.